now. Great, and yeah, so just to kick things off, welcome everyone to today's open space where we're going to be talking about decentralized economies and token economies. I'm Bowen Feng, the community builder at Systems Innovation. And just to kind of briefly kind of introduce what these sessions are about, the purpose of these open spaces is for kind of just to provide a regular digital open forum where systems innovators can discuss topics of interest with like-minded people. And I'd like to thank Jeff and Michael for being so kind as to offer to give a presentation on this topic today. And just to introduce them, Jeff Emmett is the token engineering researcher at the Common Stack, which is a very interesting project, which he'll be telling us a bit about today. And we also have Michael Zargham, who is the CEO and founder of BlockScience, and who is a complex systems scientist and architect. And together they're going to walk us through what token economies are, how they work with reference to the Common Stack project, as well as Michael's work on BlockScience. And so on that note, it's a real pleasure to pass on to Jeff and Michael.
Great. I'll just share my screen here so everyone can see. Just to confirm, everyone can see our presentation here?
Mm-hmm. Yeah, I can see it.
Great. Okay. So really happy to be invited here by Systems Innovation, and really love, I've been following everything you guys do with complex systems for a while now. Actually, I think it was Zargham that initially pointed me in your direction because of all the research on complexity and the great content you guys put out. And a lot of what we've been working on, both at the Common Stack and BlockScience, is applying complex systems. So, complex systems engineering and how we use these tools for social impact. So one of the, your point, Bowen, it's not all about the profits. It's about how we create more healthy democratic and social systems to, navigate the challenges that face us in the future. So that's what we've been working on over the past year and a half or 2 years at the Common Stack. And of course, Michael Zargham's research goes back much longer than that. So we're really taking a lot of that kind of like those academic concepts like conviction voting, which we'll talk about in a little bit, and taking it from an academic theory into applied engineering. So why are we doing this? Of course, it's important to start with the why. And we feel there's a need to scale social responsibility. So our top-down governance systems are failing us, especially in these challenging times. Climate change, biodiversity loss, even COVID response. We're seeing that these top-down governance structures just aren't responding with enough speed or context to deliver solutions that are useful to people and the planet. So following the Elinor Ostrom's research into the commons, with polycentric governance, we can actually give power back to communities to self-actualize and make decisions for themselves that are best for their context. And we have a theory that these communities, when connected in networks of novel tools of governance and coordination, they can make better decisions that match their needs on the ground. So we're working to build that toolkit of governance and coordination tools so that we can increase subsidiarity, push decisions down to the community rather than having a federal government that's trying to make decisions for a very, very large number of people. And we're just seeing that isn't meeting the needs of people on the ground in today's day and age. So this brings us into complex systems. So maybe I'll let Michael give a bit of a introduction on complex systems here.
Sure, and this audience is pretty familiar, so I won't belabor it, but an important aspect of complexity is that the properties and phenomena that we care about, they sort of come from something that is greater than the sum of its parts. And so I tend to back this out from a general systems theory lens, which contains, wide range of systems that may or may not be complex. But as we get into social and economic systems, we're sort of zooming in on something that has these dynamic, networked, adaptive, and multi-scale properties, and they tend to be characterized or characterizing of complex systems and the topics that get discussed in this community. And it's important for us actually in the reverse flow when talking with people in the like token economic and decentralized organizations, communities, to help them understand the key concepts from the complex systems field. And so we get into this discussion of how things evolve over time, the effects of networks, and the various adaptive processes at multiple timescales that actually result in the trajectories of these organizations. In terms of the practical, architecture of such a system, we actually leverage quite a bit of the applied systems theory in physical systems, but we have to be very careful about what's mechanistic and what's not mechanistic. So in the case of a traditional engineering discipline, though, there's some really important concepts. One is the sort of holism of the system, that you don't sub-optimize the parts, you actually want to define the overall system goals. And in our case, those system goals relate to sustainability, they relate to sort of these permissive systems, they allow people to participate of their own free will, and that they don't force people to stay, they don't have the same level of lock-in. So we end up having this sort of panoply of goals that we work against, similar to an engineering design problem, but unlike sort of pure software engineering as a whole discipline deals with multi-specialization. It's about managing the complexity of the system so that the users and participants are not being, unduly burdened, while at the same time looking out for their good. In our modern sort of AI platform systems, we see a lot of the system architects architecting the system to maximize profit for the system owner, whereas an engineered infrastructure is actually generally first and foremost a public good. And in fact, the public good and the safety of that public actually supersedes the fiduciary duty or the goal to make profit. So in analyzing the sort of design and development procedures in the engineering institution, or the field that's responsible for managing the relationship between technological infrastructures and humans, we actually see that there's a lot to unpack and apply for our social systems. We can go to the next slide. And in particular, kind of talking about how computational social science interrelates with the sort of physical systems analogies, we have to look at the difference between our process models, which are maybe deterministic or white boxes. They represent rules or mechanisms, or, if I do this, then that will happen, or if I do this, this will happen, which affects me, but it also affects someone else in a specific way. Nonetheless, there's always going to be some expressive element or the open aspect of the system, and we see this in the relationship between, say, agent-based models and sort of dynamical system models. Dynamical system models tend to be good that in the sense that when you do this, this will happen, whereas agent-based models tend to be a bit more like, hey, I observe the world and I decide to do this, and there's an aspect of an expression. And so we look at the way that models and data and the sort of openness of these systems leads to emergence, and actually look at the extent to which we can design, rules, process models, in procedures themselves, so that the systems effectively capture the expressed information and drive it towards some outcome that is maybe not knowable a priori, because it's actually a synthesis of the expressed preferences of the participants. And this comes from a careful acknowledgement of the strengths and weaknesses of multiple elements of theory and what aspects of them are practical. You can go on to the next slide. In a economic setting, in terms of policy making, we can kind of reason about these feedback loops in a sort of micro, meso, macro framing. This cites back to some work by Jason Potts and some collaborators, and we really think about the difference between the system level behavior, which is emergent, the agent level behavior, which is some response to both private information and the rules, incentives, etc., and that we really actually build a bridge between these two things at the meso level through some policy goal setting and some sort of mechanism or incentive design that leads to the sort of game or the world or the landscape the agents are are playing in, and the challenge is to find the right balance between sort of some structure and the degrees of freedom necessary for agents to express their real preferences and not to be overly anchored or sort of pressured into some outcome that is desired a priori by the system designer. And in sort of existing governance systems like for example, the US voting systems, there's like well-known problems with things like gerrymandering, where you're like manipulating the boundaries of regions in order to influence the outcome of the voting process. That in some way is someone, you know, manipulating the rules in a way that drives the desired outcome of the manipulators, rather than designing the rules to be good signal processors, where your actual goal isn't the outcome, your goal is the procedure of synthesizing or sense making the information embedded in the private signals of the agents. And again, we don't have direct observation of that. These mechanisms are tools through which we can try to get that information into the whole and achieve some collective intelligence. Yeah. So in the context of decentralized organizations, you know, we talk a lot about these different layers of feedback, and, you know, to avoid going too deep into this slide, I will just note that this is a slightly more detailed version of the previous, but with something very explicit about the different kinds of feedback loops. So we have agents interacting within a technical infrastructure, and that's just their day-to-day doing stuff. Then there's a computational constitution, which encodes the access controls, rights, privileges, and basically any policies about who can do what under what conditions. And even if an individual agent, say, you know, gets a new permission, then they get the rights associated with that new permission. So you can have this sort of initial constitution that is encoded in software, but you still need this outer feedback loop over governance, because no matter what, eventually there's going to be some shift, some deviation between the sort of model that is the system design and the real goals of the human participants and their actual, you know, what they need from the software, from the tools, etc. So we have a look at the way that this appears in DAOs and the difference between the constitutional or sort of rule setting layer and the implementation of that, for which I recommend checking out some work on DAOs as a new kind of institution. That was work with researchers from Harvard and Oxford, even though it's just a Medium article. So some collaboratory knowledge sharing. You want to jump to the next one?
Yep.
So kind of zooming out a bit, I think it's important to recognize that these aren't just individual decentralized organizations. What we are observing and really excited about is that this polycentric governance is being realized in the form of these sort of hierarchical networks, where you have literal communities of communities with small groups doing cool stuff, maintaining what they build, sharing and educating. And rather than having a sort of organizational superstructure, you see a lot of interactions. And so, you know, we use this slide to sort of show some projects that we have worked on, the Common Stack and Jeff and I in particular, and how the organizations, small organizations and some large ones, collaborating, end up collaborating in these little complexes, and that you can start to piece together a sort of superstructure or a landscape of collaboration that is in some ways a bit like a shape of cyberspace. There's like an ability to move through, you meet people, you work on projects, those projects go into production environments, and people use them to maintain and interconnect their communities. The next slide is, oh, go ahead.
Yeah, just to give an analogy here, this is also, you know, you could consider this is how mycelium works in the world. So this is decentralized networks in nature. You know, mycelium is the threads of mushrooms. It's the largest organism on the planet, and they seek out resources. They coordinate in a decentralized fashion. They don't have a brain that's telling them what to do. So it's a hierarchy of bottom up collaboration. So this is what we're witnessing in the decentralized organization space right now, which is really exciting.
funny because I would almost call it middle out, because so bottom up can be rough, right? Sometimes you don't have all the coordination that you need, and top down can be overly controlling. But this sort of middle out basically allows us to have community scale self-actualization, in the sense that a sort of group sort of emerges, and maybe they have rough consensus and it's some shared enthusiasm, and then the sort of base layer that allows their project to sort of, you know, grow or at least gain traction might involve some more people joining into that community, so sort of from below. But at the same time, they're not creating supersized organizations, you know, having big mergers and whatnot. Their relationships with other organizations are peer-to-peer, so you get a sort of nested peer-to-peer relationship, or a fractal-like relationship, where you get really small pods inside of slightly larger, you know, decentralized networks inside of slightly larger decentralized networks that, you know, maybe start to look like federations at the larger scale. But all that we're really seeing is a web of interconnected projects, which kind of brings us to the last slide on the current state of decentralized organizations, with a map of some projects that, back one, yeah. So this is from metagov.org. It's a project called GovBase, with one of the researchers I mentioned earlier, Joshua Tan, and he's been working on curating this database called GovBase, and I've been doing a little bit of work sort of mapping it out. And this is a simple sort of bipartite graph view of project and tools, but you know, broadly speaking, there's a ton of data in GovBase. We're curating more and looking at ways to actually build landscapes like the theoretical drawings we had, but actually using data from real projects, real collaborations, working in tools, helping each other build those tools. And there's a lot of like loosely connected webbing happening with the use and reuse of tool sets, people being members of multiple projects. And there's a lot of very interesting things going on the sort of frontier of these institutions. Which sort of, go ahead, Jeff, why don't you take over? We're going to switch to talking about Common Stack a bit.
Yeah, so this is where the Common Stack has kind of recognized that there are a lot of groups that are using similar tools or in need of similar tools. And the Common Stack is looking to build a library of collaboration tools that are modular and interoperable, and designed using token engineering principles modeled in CAD, so we can understand the systemic effects of these tools when they're combined. So the end goal of the Common Stack is to create, you know, an age of cyber-physical commons. So these cyber-physical commons can operate kind of like a platform cooperative, if you think of it that way, or a corporation that is maximizing for community inclusion rather than profit maximization, or community benefit in whatever way that community defines it, right? So these are tools that can be picked up by a group of people that want to make decisions around how to fund shared goals, how to raise those funds, how to make decisions, and how to achieve collective impact. So this is the main goal of the Common Stack, and we've laid out a library of tools to achieve a cyber-physical commons, and we've been working on these tools piece by piece. And one of the first of those is questioning and challenging our existing voting systems. So voting systems are actually an interesting signal processing problem. You know, we go from people who have private, distributed, continuous, and time-varying preferences, and we try to translate those into public, centralized, discrete events. So in other words, we want people to translate their time-varying continuous signals into a time-boxed yes or no. And in that signal processing transformation, we lose a lot of data. So this is what's holding up, in our opinion, decentralized decision-making. Even in the DAO space, you know, voting is still, you know, here is a block of time where we vote yes or no on various things, and that doesn't capture enough of the information that we need to make these kinds of decisions.
think what's interesting here, at least for me, is that when you recognize this as this kind of signal processing problem, it becomes immediately obvious that there's no unique procedure, because there's no, it's a dimensionality reduction. So it's intrinsically a dimensionality reduction, which kind of brings you back to arrow and sort of the like impossibility results that basically say that there's no way to find a perfect voting system. And the truth is that's because you have to go from a very high dimensional thing to a very low dimensional thing. And deciding what procedure will do that reduction results in a different answer. And that different answer is going to have different errors over all of the individual private preferences. And there is, mathematically no unique solution to that problem, which brings us to the realm of policy, where the subjective choice of which reduction you use is actually no way to make it objective. So we call it policy. Go ahead.
Right. So when we're applying that policy, we need to understand that that may be different for different communities or different groups. So context is king. When we're using conviction voting, that doesn't mean this is a one-size-fits-all solution. We need to understand that there are different ways that we can allocate who gets to vote or how much weight they get in voting. Maybe we want it democratic where everyone has an equal say. Maybe we want meritocratic where people who contribute more funds, labor, time have more say. It really depends on the system and the community that's using conviction voting. So we understand that the context of these systems is really important, and that there's no magic bullet solution to governance. So just want to put that out there with conviction voting. It's a tool, not a silver bullet. So how conviction works? Conviction voting works. It's essentially it's not so much voting as preference streaming. So we're continually expressing a signal to the system. So here we can see we have 3 users. They have varying amounts of tokens, and they choose to support a proposal with some proportion of those tokens. It may be all, it may be none, it may be somewhere in between. And those votes can be changed at any time. So what happens when someone votes, their tokens don't actually leave their wallet, but what it does do is charge up this conviction like a battery. So it's like a capacitor almost. And when this conviction hits a certain threshold level, the proposal passes. So the tokens charge up, they stay with the users, and when the proposal passes, you can kind of see a real-time community signal over how much in favor this proposal is. So if something has very little support, then the signal will be low, it may go up, it may go down. So this is more closely matching the actual desires of the community in terms of a transparent signal.
And by analogy, you can think of this a bit like a neuron firing. So what's happening is that these potentials are building up. All of the participants are providing their some amount of energy. It's charging up over time, and if the activation potential is achieved, then the neuron fires and the proposal passes. Otherwise, it just doesn't pass, and that means that some things may never pass. They might get taken down later, but there are other procedures for removing things. Ultimately, this one little slice is about sort of bio-inspired signal processing for collecting, as we said earlier, a spatial and time varying noisy signal and actually fusing it into a single discrete event. And it turns out that we see this in nature already, so the algorithm is actually designed to mimic that.
So when we talk about analyzing these systems using agent-based models, we need to initialize these systems. So on the right-hand side, or on the left, I suppose you can see a line of participants, and on the right, you see a line of proposals, and each participant may or may not choose to support the proposals that they have an affinity for. So we have to initialize this system. If we want to understand what Jeff wants to vote for, what Z wants to vote for, what Bowen wants to vote for, and what they don't want to vote for, we need to set this up in the model. So on the right-hand side here, we can see this is a list of 7 different proposals by maybe 25 different participants, and each participant has an affinity between -1 and +1 for each proposal. So in other words, how much do they like or dislike these various proposals? So this just maps the agent preferences to each proposal using graph structures and computational social science, which we discussed earlier, using CAD-CAD. And CAD-CAD is a complexity respecting modeling tool, modeling and simulation tool. So when we now input these initialization conditions into the model, we can see how they interact. So when we run the model, we can see, again, this is the same graph. So along the left-hand side, each dot is a participant. On the right-hand side, each dot is a proposal, and the lines in between are support from participants to particular proposals. So we can see when we run the model, these proposals are receiving support, they're aggregating a community signal, and they go from blue, which is a candidate proposal, to green, which is a past proposal. And that means funds are then dispersed and work can begin on carrying out the proposal. So this is a way that we can basically run through the model and confirm that it's behaving as we expect it to, and that we can understand the deeper complexity of how all of these different interactions occur within the systems. So here's a different plot that we got from the CAD/CAD model as well, and it's basically monitoring how these systems behave over time. So you can see there are various numbers of candidate proposals, or this is actually in funds, but I mean funds are allocated towards proposals. So we can see the amount of funds that are asked for in candidate proposals, how many go on to become active proposals, how many become completed, how many were killed, etc. And this allows us to understand and uncover systemic failures of these systems before we implement them in real world systems.
Yeah. It's important to note that like this particular simulation is from a sort of pretty wide family of simulations where we separate, again, the algorithm sort of core logic from the social science model, and then we look at the ways that we can change the social science model and look at the resilience of the algorithm to the assumptions that we literally don't know. So we're looking at some basic heuristics around, new funds are arriving if a lot of projects are succeeding, people are happy, a project that has insufficient support for long enough is killed or removed from candidacy. We have some probability that a project that got funded fails, which creates a negative shock on sentiment and reduces the future funding. And when you tune the parameters of the social system, you can see different outcomes. So you can construct failure analysis, find these sort of regions of sustainability that if you fail too much, or if you have maybe too slow or too fast of a process, the feedback loops that make this sustainable might break down. And so we use these models to actually help test the boundaries of our assumptions and look at when we can expect them to be successful, when we can expect them to break down, so that when we're putting these things into practice in real life, we're actually able to sort of interpret things, steer away from the boundaries, and sort of exercise the discretion aspects of both design and maintenance of an ecosystem in a healthy way. You can go ahead.
Yeah. So once we run these simulations through models and ensure that we've captured at least some of their unintended failure modes, we can launch these in small test deployments. So actually, conviction voting has been in production with IHIVE for the past few months, and they've been doing small-scale testing of using the conviction voting model to pass proposals. So you can check that out a bit more on onehive.org. And of course, as we discussed before, the context in which you apply conviction voting is really important. So there are many different factors to consider when implementing conviction voting. So essentially, these tokens are packages of rights. These rights give you certain levels of access control. These may or may not be tokenized. They have various attack vectors. And we can address those attack vectors in various ways. So given that we are at the early days of this kinds of novel collaboration, a lot of the current solutions are community norms to fighting, for example, how you may game adding a proposal into the system, until we have the ability to add tokenized access control at some point in the future. For the time being, we're addressing these attack vectors through community norms. But it's very important to consider not just how people vote, but also, everything that goes around that system when we're applying these in a holistic context.
Part of the goal in this particular grid is to point out that this is a subsystem in a broader system, and that our pilots with one hive have these sort of acknowledged interfaces, and in fact there are designs for solutions to sort of plug things together. So, in terms of the identity, there are tools like Bright ID. There's also, various policies around, fixed allocation per confirmed identity based on whatever identity confirmation policy you use. You can use a quadratic voting, which basically means that once you have strong identity, you can make it so that more votes from the same identity have diminishing returns. In terms of, scaffolding proposals after they're passed, there are tools like GiveF that allow you to have a structured escrow and payouts as the projects are completed. There's actually like a bunch of modules that need to be able to plug in together. And so as systems engineers, we really work hard to make sure that we simultaneously scope down to something that we can work on that's tangible, but still recognize the interfaces so that you can build components, plug them together, and achieve system level goals.
And then once we, complete these small-scale deployments and tests, more experiments are coming down the pipe. So it's really exciting to see Aragon is launching a conviction funding pilot, actually starting tomorrow, which will be allocating $65,000 approximately worth of the Aragon Network token to community proposals using conviction voting. So you can check this out on the aragon.org blog. Link is below, and we'll make sure to share this as well if anyone wants to follow through and check this out a bit deeper. So essentially what we're trying to build towards is a future of computer-aided governance. When we're managing social systems with high levels of complexity, we can use digital twins to help manage that complexity so that we can make meaningful decisions in the face of all sorts of information that is hard for us to parse and understand. Of course, when those digital twins are opaque and proprietary, for example, if they're controlled by governments and corporations, then these could be considered tools of authoritarian control. But when these models are open source and transparent, which is our whole angle with the Common Stack and CAD and BlockScience, these now become useful community sense-making tools that allow for data-driven discourse in collective decision-making. So this is kind of a make or break because there is so much power in data, and most of the models that are used in today's day and age are closed. We don't have visibility into the assumptions made, or, as Zargham mentioned earlier with gerrymandering, there are all sorts of ways that these systems can be manipulated for a preconceived outcome, which may not suit, the needs of a democracy. So ultimately what we want is for people to be informed and participate in open algorithmic policy so that we can maintain healthy democracies in the information age and avoid capture by profited interests, essentially. So how we do that is with a complex systems engineering ecosystem. So some of you everyone here is familiar with complexity and complex systems. The token engineering community is essentially, the discipline of applying that complexity science into tokenized ecosystems. BlockScience on the right-hand side here is an engineering design firm. So there's quite an overlap between the work that BlockScience does and the token engineering community. The Common Stack is applied research, token engineering research, and Michael Zargham's academic research from his PhD and previous work. There is an academic sphere as well. The University of Vienna Crypto Economics Institute has played a large role in pushing forward on the academic research. And of course, where all of these circles overlap, there's CAD, which is methodology and tooling for the simulation and modeling of these complex systems so that we can understand better where they may fail and also have the ability to look forward and say, if we make these kinds of decisions, what will happen in this system as time evolves? So when these all come together, we have a much more holistic framework for applying complexity and applying complex systems, and being able to use these tools for the betterment of humanity. And if you'd like any more information, we have some follow-up links for CAD/CAD, for the Common Stack, and for BlockScience here. We definitely encourage anyone who's interested in these to get in touch, because this is an area that needs more minds and more talent. And we're very excited to move forward with this kinds of research.
Okay, fantastic. Well, yeah, thank you very much for that. I think it was a really useful kind of introduction into, I mean, at least what I find to be the very, very fascinating work in this space. And yeah, I mean, I'd love now to kind of hand over to the other audience members, and, you know, maybe given there's a few of us on this call, we would like to maybe just put our hand up if you have a question or any thoughts that you'd like to share. You can do that, by the way, by clicking on participants, I think, at the bottom, and then there should be a button to click raise your hand. But while we're waiting for that, I think one question I had, and apologies if you kind of covered this briefly, was because there seems a lot of in a lot of these kind of blockchain ecosystems, the way of doing things is that you have one token which may be of monetary value within the organization, and another which you can use as kind of like a governance token. It's not really monetary, it's more like voting rights. But from my understanding, sometimes you can actually buy those governance tokens with money. Well, you know, that type of monetary value. How do you kind of, in these systems, prevent unintentional sellout, where somebody who's rich just kind of buys all the governance tokens and calls the shots?
Yeah, there's a lot baked in there, so I'll try to unpack it a little bit. So the first thing is to really rethink about how people think of tokens and blockchain ecosystems in a way, because blockchains are, in particular, the ones that we're talking about, are state machines. The tokens are really just state information. So they're information about the state of the world. And so when you go to associate a token's mapping to an address or an identity, you're really encoding a package of rights. You're saying, you know, the state of the world is this relative to me, and that state is associated with some methods, and those methods allow you to assert the rights that your tokens encode. Now, some tokens have transferability, which is sort of the things that you can buy and sell, and there'll be exchanges, and monetary value tends to appear whenever it becomes possible to transfer. So like proving that you have it allows you the method to send it to someone else. The moment that exists, you see markets form, liquidity pools, prices emerge, and there is nothing wrong with that per se, but to your point, you need to be really careful about when you equip a token with that. Now, in the Common Stack, we actually deal with both kinds. So we have a token called C-Stack, which is CSTK, which is actually non-transferable. It's something accumulated through participation in what we call the trusted seed, which is a sort of, you know, I'll call it a gated community, but it's open in the sense that anyone can join, but there's some public information procedurally about what you would go to do to sort of kind of get skin in the game, so to speak, whether it's contribute labor or funds, but like contribute towards the success of the organization. There's some social validation built in. They're not pseudonymous. You have to be a person. And those tokens are non-transferable. They don't have a market value, and they can be used in some governance processes. But in a lot of the commons designs where pseudonymity is important to people, then you don't actually want to force things through that tight of a procedure. And in fact, markets do a really good job serving the function of sort of, you know, essentially you're using plutocracy to mitigate Sybil attacks. So if it costs you money to gain voting power, then you can't just freely accumulate voting power. But to your point, that means that a wealthy party can come in and sort of jerk around a system. What's really cool about this, though, is that there's there are two kinds of mechanisms in a blockchain system that can reject that pretty effectively. One of them is, as long as you have a proper social layer, you can have sort of veto machinery where someone who does something that violates the spirit of the rules, even if procedurally they followed them, can be sort of rejected through another procedure. Aragon uses courts. There are a variety of mechanisms that can fill that function. And the other is a sort of a last resort, but people fork things. So if someone, whether it's financial or just pure politics, if a decision that is sufficiently big is passed, the organization can fragment into two. And so what's interesting about this is it might seem like a bad thing, but actually if you take genetic analogies, this is pretty good. It means that if something so ideological splits the org into two components that are, even if they're asymmetric, then if that decision survives, it can be one, the other, or both that actually persists. So there's a lot of interesting like second order and adaptive dynamics associated with the way the financial and the political, or the economic and the political aspects of these systems are playing out, which is part of the reason I generally consider it a frontier. I would say these are the right questions to ask, but until we observe more of these systems, we don't want to just throw them out and say, hey, it's bad to have governance tokens that you can buy, even though obviously a lot of bad things can come from it. I see interesting second order effects correcting for that.
And I think, yeah, to add on to that, we are in such an early stage of the blockchain decentralized technology ecosystem. And Dr. Zargham made a really good point that until we have strong identity, we can't have democracy. Because if we just said, okay, everyone in this community, it's one person, one vote, well, then I can just go and create 100 addresses and then I get 100 votes and I take over the system. So actually like plutocracy or governance by like who has the most money is not the best system, but it's better than having everyone go and Sybil, create 1,000 accounts and just take over the system. So until we have strong democracy or strong identity through something like the Bright ID protocol, which is increasingly, being used by various projects. But again, this is a very early stages of this technology. But when we get into that, we can have things like quadratic voting as well. So quadratic voting speaks to plutocracy as well. So if you are able to put in $1,000 and I'm only able to put in 10, you shouldn't have 100 times the say, but you should have more. So we're basically trying to balance this optimization.
And I want to point out that even this is context is king, because you have to design these policies on a system level. Even if you do a meritocratic system, which people tend to like, where your voting weight is determined by contributions, there's also a representation issue that arises. Some people can actually afford the time and energy to participate or have certain training and skills that would give them disproportionate vote, which can skew the outcome of decisions. So even when it comes to a question of who is represented in a decision-making process, there's a lot of, there is no unique solution. Therefore, if the problem you're trying to solve has a representation issue, then maybe you need to find ways to allocate voice to people who may not be able to contribute anything explicitly.
Mm-hmm. Yeah, thanks for that. And I absolutely get that it's early stage and a lot of the answers will come through trial and error. And, to kind of look at a very new emerging system and say, oh, not every single thing is figured out, so therefore, it's going to work or not work, is obviously too early to make the call. And, one thing, just as a last point before we go to the others, that I find very encouraging is that there's kind of this inherent ability to experiment in this space, and that once you've set up one kind of overarching government system, let's say, it's quite difficult to kind of change that fundamentally once the ball is rolling. But with these, you can kind of change it in some fundamental ways. So thank you for that. Great. So I can see someone's got their hand up, and we also have a comment in the chat, so we maybe you can bring those forward. QCOM BTD, I see you've got your hand up. Would you like to unmute yourself and share your thoughts? I'm not seeing anything yet. I can see you've unmuted now.
Yeah, well, I had my hand up. Do I get a question?
Yeah, of course.
Just cool. Sorry, my internet was having problems there. I actually missed quite a bit of the presentation. Unfortunately, I'll watch it afterwards. So I hope my question is redundant. I had a couple of questions. First one was for Jeff. I looked at the website, the Common Stack, and I know you're developing, as you said, the project as this kind of set of modular components to form a minimal viable commons. I was wondering how many of those you have developed, and what are they? What are the kind of key ones, key components there that you think, well, you're trying to get the low-hanging fruit first? Which ones you have developed at this stage?
Right. So the minimum viable commons, as we have called it, is composed of 4 components. And these are the basic components that we, working in the open source space, have identified are necessary for getting things done in a group. So one is raising funds, and our component for that is the augmented bonding curve. Another component is making decisions over how to allocate those funds, which we'll use conviction voting, which we talked about in this presentation. The third one is the giveth proposal engine. So in other words, once we decide as a community which proposals we will pass, well, what happens with the money? You know, we should probably hold it in escrow and then issue it once the milestones have been reached. Because obviously when we're doing this at scale, we can't just hand $1,000 to someone and expect them to do work. They may just run off to another country and we never see them again. So an escrow service for funds would be the third component. And the fourth component is the Commons dashboard. So this is essentially using CAD as a digital twin of the system so that we can run through simulations and propose changes to the system to understand how they might impact you know, in these complex socio-technical systems where we can't really reason about, you know, what happens if we raise the tax rate from 5% to 10%. Maybe everyone will leave. Well, let's run it through a simulation and read it from the dashboard how this may interact. So those are the 4 components.
And I think that the Commons Analytics dashboard is something that is pretty close to my heart. And I think one of the challenges is the complexity management there. So inevitably, to our earlier points, there's a degree to which the people who build those analytics have the ability to sway the perception of things. And so we view it as a sort of open source mirror by giving, like, you know, some digital twins of systems made up of these components and actually openly acknowledge the points of subjectivity. We make it a lot easier for people to run their own simulation. And it's not just here's the analytics dashboard, it's here's the experimental apparatus that says, well, here's the system state as estimated from this model and the observed data. And by the way, if you want to change a heuristic, a change in assumption, run a scenario, we're actually talking about providing that as well as part of these. This is sort of how the CAD models work. And that allows for a kind of informed participatory governance that doesn't require people to have the same level of technical savvy to get the benefits of this sort of community scale mirror.
Thanks for that, Joss. Does that answer your question, or did you have
anything
else?
It does, yeah. I have another question, but if someone else wants to go, then I'll let them.
Well, I see Edgar Navarro, you've shared a couple of things on the chat. Is there anything you'd kind of like to add? You say that, you know, there was and just maybe we can go back to you afterwards, but you said there's a debate over identity and anonymity for full democracy practices. Is there anything you'd like to share around that? Feel free to unmute yourself if you'd like.
Oh, thank you very much. No, I just recently joined the debate or the presentation, so I also didn't have the opportunity to see the presentation at all, but at the end you talk about also quadratic voting and so on, and some governance models in this decentralized system. So I just wanted to, I put here a link where it was a session a couple of hours ago in the Radical Exchange Initiative, where they also presented some very interesting practical practices, I mean, using this different kinds of quadratic finance and quadratic voting models with tokens and so on. So it could help you for the debate.
Yeah.
And
I think it's a good idea to follow. So Kevin Iwaki's work is great. He's been sort of pushing the practical applications of some of these alternative ideas. And actually, you know, one thing that we've played around with is the sort of algorithms that come from composing the sort of conviction mechanism, which is time-based. and the quadratic, the use of the quadratic, it's actually the radical that appears in the quadratic funding model that essentially takes the power of your voice, and if you talk more, you get the root of that effect that's very spatial. So if you think in spatiotemporal terms, you have the dimension over people and you have the dimension over time. And so I have worked on the conviction voting model with the understanding that time and integration operators are actually extremely common in biological sensor fusion problems. So whenever you see sort of spatially distributed information in nature, you generally see some sort of integral operators being used to trigger discrete events. But I think the family of algorithms that you can use for taking that and counting it are pretty wide. So we've not published anything but played around with prototypes that actually use both the quadratic policy and the conviction policy to cover both time and space at the same time. So kind of to our earlier conversation, there's actually a lot of white space to explore. Like, we don't really know, we just try to get the problem defined right and some candidate solutions explored and tested in real life, so we can start to see what works, what doesn't work. And especially with the complexity community, I'd like to really reiterate that we can take a lot of inspiration from first framing the problem as a signal processing problem of some kind, and then looking at biological and other historical examples of places where this distributed time varying information is effectively fused into discrete events, because ultimately that's what a vote is.
Yeah, so it's insightful. We have a very wide space to experiment. So thank you.
Yeah, thanks for that. And yeah, I'm aware, of time, and it'd be great to if everybody's able to kind of ask a question. So if you had anything else, feel free to unmute yourself or add something in the chat. Otherwise, we can go back to Joss for a second question. It's never quite as easy on Zoom, is it? Because you can't pick up so much on kind of the nonverbal signals, stuff like that. But yeah, guys, feel free to add anything in the chat or put your hand up. But yeah, Joss, feel free to go ahead with your second question.
Yeah, it's about CAD. And I guess I was talking to Jonathan in Switzerland, the BlockScience guys earlier today. We were talking about CAD. He's involved in education there. And we were just talking about, how do we communicate this thing? I understand it as a system for analyzing complex systems, but that's pretty broad. I'd then ask, how do you go about that? Or, yeah, what's the key characteristic of that bit of tooling to let us do that? I mean, one way that I'm thinking about it is kind of in terms of networks. That's how I think about complex systems. But maybe, within a minute or so, you could give a kind of what vocabulary would you use to communicate what that tool is and how it works?
Sure. Yeah, actually, there's a couple things going on with CAD. It does sort of live at the nexus of a few fields. So I'll try to paint a picture around it. So if you start with the historical application of complex systems and systems engineering, both spatial and temporal, in, I would say robotics control, aerospace, and really even some advanced, sort of large-scale government problems, you would use something like a MATLAB, which is a really powerful mathematical tooling, and it's closed source, and all the packages are toolboxes, and they're expensive, and they kind of hook you on it when you're in school and studying these fields. And what I noticed from that angle is that we need these things to be open and not opaque. And so there was a movement to sort of push a lot of that capability, that sort of skills in signal processing, control theory, the sort of cybernetic stuff, into an open source framework, which sort of brings us to Python data science, which is the sort of, I think, the sort of prototypical global scale collective that has no, central hub. It's one of these hierarchies. It's not a Web3 thing, but you look at the people who make up the Python data science community, and they're like all over the world interacting on open source repos, lots of small organizations, some funding, some collaborations, migrations of people. It's got a great like decentralized organization around it. And then we can see that that's a really fertile place for building tools that are meant to enable that very kind of institution. So CADCAD is a open source Python package in the family of data science tools. So it has easy interoperation with network tools like NetworkX. We use it with things like scikit-learn, NumPy, SciPy for statistical models. And it's in itself, it's just one building block, but its critical addition is the representation of dynamical systems. And in particular, what we call generalized dynamical systems. And I say generalized because we move beyond, real valued numbers to arbitrary objects and data structures, things like graphs. So when we put a NetworkX object inside of a CAD-CAD model, what we're actually doing is saying, here's the state of a system, part of that state is a network, and the network evolves over time. And so maybe that network contains things like participants and agents, proposals, as in the example for conviction voting. But broadly speaking, CAD-CAD as a tool is actually just a building block in Python data science. And what we actually use when we use, when we say we're using CAD-CAD is just the Python data science ecosystem. And that we're really just filling in some procedural elements associated with the decision-making and the consequences of those decisions into a kind of data pipeline. And the last point I'll make is that data pipeline can be thought a bit like a board game, where you actually code it up in rounds. We have these things called partial state update blocks. So you have a bunch, everyone sort of makes some decisions, and then the decisions consequences are reconciled. And there can be, in series or parallel, a range of sort of operations that occur, completes a round, the state has been sort of mutated, multiple times within a time step, but ultimately has one whole time step. And that pipeline then loops on itself, because like a dynamical system, it maps from state to state. So if you have the posterior state of one CAD-CAD pipeline, it's the prior state to the next one. So you've built what is essentially an ML pipeline-like architecture, but you've captured the essence of a dynamical system. And we do this through, again, these sort of partial state update blocks and a sort of separation of decisions and consequence of decision to really help encode complex interactions.
Yeah, okay, so the state machine aspect, that's kind of central to it, isn't it? That's one way of understanding it, isn't it? It's just generalized kind of state machine that can take different kind of inputs and different kind of states and think about how they change over time, no?
Right, so we often talk about dynamic games in the context of CAD-CAD, because while it's generalized dynamical systems in a sort of theoretical sense, most of the systems that we care about can be viewed as these sort of complex, heterogeneous, multiplayer games, but where the decisions of some parties are, at least loosely, if not tightly coupled with the effects on others. So you can explore things like externalities, both positive and negative, and look for, sustainable spaces in the fitness landscape. And I really like to emphasize co-fitness as opposed to just raw fitness landscapes. You're not just saying that what is success is absolute. You're saying that there's some sort of mutuality in the notion of fit. Things are fit together.
Co-evolution.
Yes. But it all depends on what model you code. So CAD-CAD doesn't give you like an automatic thing. It's like I said, it's probably best to think of it in the context of filling in a tool within the Python data science ecosystem so that the Python data science ecosystem can fulfill the needs of complex systems.
Thanks. I had unless anybody had any other questions, I had a question I'd like to ask you, Jeff, about, one thing that I picked up on dabbling around in kind of the blockchain space and kind of registering for different types of kind of organizations there is that the ideology is really amazing. And I think something that we really need more of, not just the ideology, but really with the right kind of tools to try and experiment with solutions. And obviously a big part of it is how do we create outcomes in society that are more equitable for as many as possible, kind of really incorporating a diverse range of perspectives. But one thing I can't help but notice kind of going into the space is that, first of all, the steps for me to, I'm not the most technical person in the world by any means, but I do work in IT and I have worked in IT. And, there were quite a few loops for me to jump into, even, getting a wallet and, figuring out how to buy tokens and getting, with DAO Stack, for example, I had to put a proposal to be registered into it. And, I get that those are more technical limitations, not that they want to kind of make it feel a bit kind of create the friction. But obviously the community is generally quite technical. And a lot of people come from the open source community. How much do you feel is a bit of a barrier to the growth and success of this whole ideology, given that it's quite a limited group at the moment? And what do you see how do you see that playing out, I guess, in the long run?
Yeah, for sure. I would say I'm glad things are still very small scale, because these technologies still have a lot of proving grounds, experimentation to run through to make sure we're using them in appropriate context. I think, when I talk with people about using blockchain technology, I, usually draw a parallel with like using the internet in the 80s. Before there were browsers, before web browsers, before there was email, the internet was around for a few decades. Academics were trading packets of information back and forth, but for the average person to jump into that, it was incredibly difficult, right? You needed to understand all sorts of like technical details that, were not user facing. As soon as we had the browser and you could just type in, information about cows.com, it was easy for the user because they could go to that website, use this tool. And I think blockchain will get there. Having these, public key, private key cryptography that, is just not facing people in the way that people use technology at this point in time. So I think that gives us a few years to experiment and trial these technologies and figure out where they fail before they're applied to, social level or societal level decision making. And then we realize that, we didn't account for this or that in our modeling. So I think it's great to have that small scale experimentation phase still ahead of us. I completely agree. I mean, I'm in terms of like using blockchain, I'm a great test case because I break it every time. I lose my keys to this, or it's just not user-oriented technology, in my opinion, at this point yet. So we've got a little bit of ways to go, but we also need some time for experimentation and trial and error of all these new technologies, exploring the design space, and moving forward from there.
Fantastic. Well, I'm aware we're a bit over the hour now, but thank you very much, both of you, for doing that presentation, and for those of you who joined today. We did make a recording. I think what we'll do is we'll put it on YouTube, but just put a private link. So if anybody would like to share it specifically with people they know, then feel free. I know a few people said they wanted to join, but they weren't able to make the time today, so it's good to have that. Were there any kind of final thoughts you'd like to share, or a final call to action? I know you had something in the last slide before we wrap up.
Yeah, let me pull up that last slide again. And I just wanted to let people know that we'll make these slides available in perhaps in the YouTube link. Just so if anyone is interested in following up on any of those links, we did have some sources and citations in there. So feel free to have a read through, and please get in touch if you're interested with any of these technologies. We need more brains, more resources, and more experimentation on all of this. So really happy. Thank you for hosting us, and really excited to discuss all these concepts with systems innovation further in the future.
Thank you so much for having us.
It's been a pleasure, and
Thanks, Jeff. Thanks, Chris.
Yep. Thank you very much, and have a nice evening or morning or afternoon wherever you are in the world, and hope to see you soon. Thanks, everyone.
Bye bye.
Cheers.
Thanks, guys.
Thanks.
Bye bye.
Thank you. Bye bye. Thank you.
Bye.